Approximately half a year after the James Webb Space Telescope was launched, the intricate machinery gifted us with its initial mesmerizing images. However, this marked merely the introduction to an ambitious endeavor, one that is poised to elevate our comprehension of the cosmos to entirely novel dimensions. Beyond investigating the earliest radiant formations and galaxies that materialized after the Big Bang, the Webb's mission encompasses a quest to unravel a query that has persisted throughout human history. Are we the sole inhabitants of the universe? In pursuit of unraveling this enigmatic cosmic conundrum, the $10 billion telescope will turn its gaze towards the atmospheres of exoplanets, scrutinizing these celestial entities for potential habitability. Of particular interest in recent discussions is the enigmatic signal that has recently been detected, a signal emanating from artificial lights on Proxima Centauri. The question emerges: is this truly indicative of the intricate signature of an advanced extraterrestrial civilization? Alternatively, could these reports be clarified through alternative explanations? Collaborating with you, we embark on a quest to unearth answers to these pressing queries. Anticipation builds for groundbreaking revelations and captivating spectacles within the universe. For those excited about these captivating discoveries, remember to subscribe to Cosmos Prodigy and activate the notification bell for regular updates on these enthralling subjects. Express your enthusiasm through a thumbs up, signaling that we have succeeded in maintaining your engagement with the compelling content of our videos. The question of whether we are alone in the universe has persisted since time immemorial. Given the multitude of celestial entities that twinkle above us in the night sky, the possibility arises: could Earth be the sole abode of life in the cosmos? Despite researchers having successfully identified over 5,100 exoplanets across nearly 3,800 systems, the monumental discovery of extraterrestrial life still eludes us. Beyond the challenge of confirming the existence of such life forms, there remains a lack of unquestionably habitable planets other than Earth. The vast distances separating us from these distant worlds pose a significant hurdle for conducting precise analyses. However, our closest cosmic neighbor, Proxima Centauri b, presents a different scenario. Proxima Centauri b, located a mere 4.2 light-years away, was first detected in the summer of 2016 through the radial velocity method. Initial assumptions led experts to believe they had come across an Earth-like twin due to the exoplanet's position within the habitable zone of its host star, Proxima Centauri. The habitable zone refers to the region around a star where conditions are suitable for water to exist in a liquid state, a fundamental requirement for supporting Earth-like life. Proxima Centauri b achieves a value of 0.87 on the Earth Similarity Index, ESI, indicating its similarity to our planet. Yet, the question of whether life could thrive on Proxima Centauri b or has already emerged that remains complex to answer. Our current understanding of our extraterrestrial neighbor remains limited. However, it's confirmed that recent spectrographic analyses have revealed Proxima Centauri b possesses around 1.17 times the mass of Earth. Additionally, the exoplanet is tidally locked, meaning one side perpetually faces its host star. This division results in extreme differences between the illuminated day side, which is significantly hotter, and the constantly dark night side. The estimated equilibrium temperature of the planet is -38 degrees Fahrenheit, but this figure isn't fixed. A dense atmosphere could contribute to a higher surface temperature due to the natural greenhouse effect. It's important to interpret reports suggesting Proxima Centauri b's potential for hosting liquid water cautiously. The simulation's results depend on specific orbital parameters and atmospheric composition, which might not accurately reflect the actual conditions on the exoplanet. As of now, the enigma surrounding Proxima Centauri b remains an enigma, awaiting further exploration and research. As previously mentioned, Proxima Centauri b is likely characterized by an extreme contrast between its scorching hot day side and bone-chillingly cold night side. However, This division in temperature doesn't necessarily rule out the possibility of life on this distant exoplanet. There exists a narrow zone between these extremes where conditions could support life's development. Similar to our own evolutionary journey from simple single-celled organisms to a sophisticated species, hypothetical inhabitants on Proxima Centauri b might have followed a similar path. If this scenario holds true, signs of this civilization could be detectable even from our perspective on Earth. In December 2020, a remarkable discovery was unveiled that some experts interpret as evidence of such signs: an artificially generated radio signal. This mysterious signal is believed to originate from the vicinity of Proxima Centauri. The initial aim of researchers was to investigate the host star for flares using the park's radio telescope in Australia. Their goal was to understand the effects of these radiation bursts on surrounding planets. During the analysis of data gathered over a 26-hour period, an intern named Shane Smith from the SETI program stumbled upon a distinct signal at a frequency of precisely 982.002 MHz. This signal, known as Breakthrough Listen Candidate 1 or BLC-1 for short, was later considered a legitimate contender for an extraterrestrial species' artificially produced radio signal. Adding to the intrigue, during the same timeframe, other experts identified a notable occurrence in the Proxima Centauri system: a luminous and enduring optical flare accompanied by a sequence of powerful, coherent radio bursts. However, while BLC-1 is an exciting candidate, it has not yet been confirmed as an unequivocal extraterrestrial signal due to the challenge of conclusively determining its source. To ascertain whether BLC-1 truly represents the technical signature of an advanced alien species, further observations are essential. Unfortunately, astronomers have not managed to redetect the signal, leaving room for alternative origins such as satellites or natural phenomena to be considered. Let's assume that life has indeed thrived and evolved into a technologically advanced civilization on Proxima Centauri b. Given this premise, it wouldn't be implausible to speculate that the inhabitants of this exoplanet have dedicated themselves to the task of illuminating its otherwise pitch-black night side with artificial lights over time. The connection between the potential discovery of such a technological signature and the future utilization of the James Webb Space Telescope largely stems from the insights shared by Avi Loeb, an Israeli physicist known for his unconventional approaches to uncovering signs of extraterrestrial existence. Avi Loeb has been exploring innovative methods to detect the presence of unseen cosmic neighbors, and he suggested in 2018 that the enigmatic object Oumuamua could actually be an extraterrestrial solar sail. Collaborating with Eliza Tabler from Stanford University, Loeb authored a study titled Detectability of Artificial Light on Proxima Centauri b. In this study, the researchers considered the possibility that the hypothetical inhabitants of the exoplanet might use a type of lighting similar to our own LEDs on Earth. The findings reveal that if the artificially lit night side reached a brightness of 5% compared to the day side, there would be an 85% probability of Webb detecting this phenomenon. The core principle here is that higher levels of artificial illumination enhance the likelihood of detection by the James Webb Space Telescope. Should the illumination reach 9% of the dayside's brightness, the probability of detection would rise to 95%. However, the notion of 5% illumination might seem insignificant at first glance. But this is misleading, as a point of comparison shows that our own planet's artificial illumination only accounts for 0.001% of reflected sunlight. Essentially, this means that the artificial lights on Proxima Centauri b would need to be 500 times brighter than those on Earth for us to detect them. It's conceivable that the hypothetical inhabitants of the exoplanet have utilized practical means to assist us in detecting their presence. For instance, they could deploy brilliantly bright orbital mirrors to reflect their host star's light onto the night side of their world, potentially observable by our telescopes. While the concepts presented in the study are intriguing, it's crucial to acknowledge that they currently remain theoretical. Whether these hypotheses hold any truth will depend on future observations, If the James Webb Space Telescope eventually verifies an artificial light signature on Proxima Centauri b, rest assured that we will share the exciting news with you here. It's evident by now that the James Webb Space Telescope has already made a significant impact on the realm of science, unveiling its inaugural image that has captivated the world. Without a doubt, we can anticipate a series of remarkable revelations in the coming months and years as this revolutionary telescope continues to explore the cosmos. Our journey through space is just beginning, and we're here to keep you informed, sharing the latest breakthroughs and intriguing theories. Make sure to subscribe to our channel if you're eager to delve into the discoveries made by the James Webb Telescope and the intriguing phenomena it uncovers in the vast expanse of space. We trust you found this video enlightening. Do you still hold to the principles of the Big Bang Theory? We're excited to hear your insights. Join us again soon on Cosmos Prodigy for more captivating content.